Welcome, everyone, and thank you for standing by. I would like to advise you that today's call is being recorded. If you have any objections, you may disconnect at this time. I would now like to turn the conference over to Katherine Hambleton. Thank you so much. You may begin.
Thank you, and good afternoon, and welcome to today's media teleconference on NASA's Fiscal Year 2024 budget proposal. Thank you for joining us. I'm Katherine Hambleton from NASA's Office of Communications. Today we'll hear from NASA's Associate Administrator Bob Cabana, as well as Chief Financial Officer Margaret Schaus. Margaret will walk us through some of the details on NASA's budget proposal. She will refer to the slides through this teleconference. As this is an audio-only teleconference, the slides are available online at nasa.gov/budget if you'd like to follow along. The slides will be in the document titled NASA Fiscal Year 2024 Budget Summary. In addition to the Chief Financial Officer, we will have several members of NASA's leadership team with us on the call today for questions and answers. They are Bob Gibbs, Associate Administrator for Mission Support, Jim Free, Associate Administrator for Exploration Systems Development, Kathy Leaders, Associate Administrator for Space Operations, Bob Pierce, Associate Administrator for Aeronautics Research, Jim Reuter, Associate Administrator for Space Technology, Nikki Fox, Associate Administrator for Science, and Mike Kincaid, Associate Administrator for the Office of STEM Engagement. And I'll turn it over to Bob Cabana for opening remarks.
Well, good afternoon, everyone. As Catherine said, I'm Bob Cabana, and I am really pleased to introduce the President's FY 2024 budget request for NASA. NASA's budget request is $27.2 billion, which is a 7.1% increase over the agency's 2023 enacted appropriations. This budget request increases funding across all of NASA's mission directorates and promotes U.S. leadership in exploration, science, and technology innovation in aviation and space. Furthermore, this budget reflects the administration's confidence in the agency and support for NASA's mission to explore the unknown in air and space, innovate for the benefit of humanity, and inspire the world through discovery. And with that, I would now like to turn it over to our CFO, Margaret Schaus, to provide more details on this budget. Margaret?
Thank you, Bob, and good day, everyone. I'm also pleased to share with you the details of NASA's Fiscal Year 2024 budget request. If you can join me by starting on slide 2. NASA's $27.2 billion request supports the following key priorities. It includes $8.1 billion for Artemis, which builds on the successful test flight of Artemis 1 and will enable our long-term presence on the Moon and prepare us for human exploration of Mars. Until then, it invests $1.2 billion in robotic exploration of Mars in cooperation with our international partners. This budget includes $3.5 billion to implement NASA's strategy for low Earth orbit, with funding for the International Space Station and commercial destinations in low Earth orbit. It invests $8.3 billion in science, and this funding will support over 100 space science missions and 10,000 U.S. scientists through more than 4,000 research awards. And within that science number, we include nearly $2.5 billion to provide Earth system data and actionable information to the public for both research and societal benefit. Turning now to slide 3. This budget also provides $996 million for aeronautics to continue U.S. leadership in the global aviation industry by making aviation safer, faster, and more efficient. We invest $1.39 billion in space technology research and development to develop transformative and cross-cutting technologies like nuclear power and propulsion that enable both Artemis and other NASA missions, grow the commercial space industry, and create jobs. The budget expands the reach of NASA's STEM learning opportunities across diverse and underrepresented communities, investing $158 million to engage and inspire more students as part of the Artemis generation. This budget advances diversity, equity, inclusion, and accessibility for our workforce and expands our outreach to a greater diversity of partners and stakeholders. And it invests over $3.8 billion on our greatest asset, the NASA workforce, and the infrastructure that supports them. Within this budget, NASA explores the unknown in air and space and innovates for the benefit of humanity, with over 3,000 commercial partners, including over 2,000 small businesses, creating jobs in all 50 states And NASA works with 135 countries around the globe, hundreds of schools and academic institutions, and with numerous U.S., state, local, and tribal government partners. Before I dive into the theme-level details of the budget, I'll first tee up 4 key priorities in this budget, many of which span multiple accounts. And this will include building a robust presence in low Earth orbit, establishing a sustainable lunar presence, protecting our home planet, and investing in our people and infrastructure. Let's turn now to slide 4. Here we show the International Space Station and our robust presence in low Earth orbit. And through the ISS, we've enabled continuous human presence in LEO for more than 20 years and will operate through 2030. NASA's FY24 budget includes all the elements necessary for a safe and seamless transition in low Earth orbit, from the ISS to new commercial destinations in LEO, for which NASA will be one of many customers. This total $3.5 billion budget is depicted in this graphic. You should see at the top in yellow text where we represent ISS and space transportation elements of the budget. And that includes support for ISS operations with our international partners and ongoing commercial crew and cargo launches. It funds groundbreaking science, research, and technology development that reduces risk for long-duration space travel and improves life on Earth. And this budget also plans for the station's end of operations by requesting funds for the safety orbit of the ISS at the end of this decade. Now, in the bottom of the slide, you'll see in blue text, we represent our investments in commercial LEO for partnerships with U.S. companies to develop commercial destinations that will be in orbit by the late 2020s, prior to the end of operations for ISS, to ensure that there is no gap in U.S. presence in LEO. And through these efforts, NASA intends to stimulate demand, catalyze new markets, and transition to a long-term, sustainable, commercial human spaceflight economy in low Earth orbit. Turning now to slide 5, I'll talk about establishing a sustainable lunar presence to maximize science and economic potential. Now, through the Artemis campaign, NASA is partnering with the broadest exploration coalition in history. With a budget request totaling $8.1 billion, we advance U.S. leadership in space exploration. And with Artemis, we will explore the moon's south pole and conduct the science, technology demonstrations, logistics, and operations needed to establish a sustainable and enduring human presence. In doing so, we will expand our scientific understanding of the moon, open up new economic opportunities, and pave the way for human exploration to Mars. This graphic represents the integration of key Artemis elements that appear in this budget. Starting on the left, you'll see the Gateway, which will serve as a multi-purpose outpost orbiting the moon for NASA and our partners. The Gateway will allow astronauts to conduct science research in lunar orbit and enable human exploration and scientific research on the lunar surface. Both in early and later stages of assembly, Gateway will enable crewed missions in lunar orbit where astronauts will live, work, conduct research, and prepare for lunar surface missions. Below that on this slide, you'll see the Lunar Terrain Vehicle, an unpressurized surface transportation system that will significantly extend the range of crew excursions and enable more scientific research, resource prospecting, and exploration activities to be conducted. In the middle of the graphic, you'll see the human landing systems that will transport crew to and from the lunar surface, and this includes funding for sustaining lunar development, for which the request seeks to support competition for missions beyond Artemis 3. You'll also see in the graphic a surface pressurized rover that enables long-duration mobility for more productive lunar science and exploration. And the pressurized rover will expand the range of excursions even further, allowing crews to perform longer duration research and exploration activities. To achieve even longer stay times on lunar surface, NASA will deliver a surface habitat that supports up to 4 crew. We will create power on the lunar surface by demonstrating fission surface power, and we'll develop critical technologies for in-situ resource utilization that enable the local production of fuel, water, and oxygen. And what we learn on the moon with our commercial and international partners will ultimately inform our human exploration of Mars. So let's turn to slide 6. Or the title should be Moon to Mars Exploration Architecture. And this slide shows on the left the technologies I discussed that will enable science, exploration, research characterization, and operations on the moon. And as shown on the right, will allow NASA to conduct analogous missions on Mars to reduce risk and optimize operational concepts for the first human mission to Mars. And while not graphically shown, I want to highlight that our Moon to Mars objectives include a steady pace of basic applied and enabling science, such as lunar and planetary science, heliophysics, physical science, and human and biological science. And that also includes conducting science and collecting data through robotic exploration of Mars, for which this budget funds the Mars Sample Return Mission and the ExoMars rover mission, both in partnership with the European Space Agency. So moving on to slide 7, I want to talk about our current Moon to Mars manifest. And this graphic lays out those major mission activities through the budget horizon of 2028, which you'll see in the navy blue highlighted years in the center, with milestones that are based on NASA's FY 2024 budget request, as well as beyond the budget horizon with notional milestones through 2031. This graphic also brings together the Artemis contributions by mission directorate, which are noted in that first column. So starting with calendar year 22, I'll just highlight some of the major activities. We saw, of course, the successful Artemis 1 test flight, as well as launches of Capstone and Lofted. In 2023, through the Science Mission Directorate, we will begin a steady cadence of commercially provided landings with robotic payloads on the lunar surface through CLIPS, and those are outlined in boxes. And those will allow us to characterize the lunar south pole in preparation for human landing and conduct science at multiple locations on the lunar surface. In 2024, Artemis 2 will launch, and that same year, SpaceX will conduct their uncrewed lunar landing demonstration in preparation for Artemis 3. Under space technology, that row in navy at the bottom, we will fund important work in space nuclear propulsion, including a preliminary nuclear thermal engine design and nuclear electric propulsion concept vehicle design. In 2025, NASA will begin building up the Gateway in lunar orbit, and as early as 2025, Artemis 3 will launch, returning Americans to the surface of the Moon. Also during this time, you'll see in that row in purple for space operations, the NASA will be upgrading our lunar communications network to support lunar exploration. And in that bottom row for space technology, starting in 2023 and across the time horizon, we will also be conducting many technology demonstrations delivered by commercial landers to mature capabilities needed for transportation and operation on the Moon and Mars. Capabilities critical for sustainable presence will be matured during this period, including fission surface power and a pilot plant for in situ resource utilization. Also, as early as 2027, NASA and our international partners will begin a series of launches for the ambitious Mars Sample Return mission, launching samples from the surface of Mars as early as 2030 and beginning a return trip to Earth. In 2028, with this budget request, Artemis 4, with an enhanced upper stage that will allow co-manifesting of large payloads for building up lunar capabilities at the Gateway, will launch. And that year begins our annual cadence of Artemis missions to the Moon, where a commercial lander will begin delivering astronauts to the lunar surface and enhancing lunar surface capabilities with each mission. I'll turn now to slide 8 and talk about NASA's investments for protecting our planet. So NASA uses the vantage point of space and its expertise in aerospace technology innovation to play a vital role in monitoring and protecting the most important planet, Earth. This request includes over $3.3 billion in investments to observe, understand, and protect our home planet through our investments in Earth science, green aviation, planetary defense, and orbital debris remediation. This includes $2.5 billion in Earth science, investing in the next generation of Landsat satellites, 4 new Earth system observatory missions, and making Earth science data available and actionable. This includes developing applications and tools to support agriculture and wildland fire management and to improve our knowledge of greenhouse gas sources and sinks. It includes $570 million to reduce aviation's climate impact, including a sustainable flight national partnership that will reduce fuel burn by as much as 30%. And it includes nearly $300 million for both planetary defense and the growing problem of orbital debris. Moving on now to slide 9. The title is NASA's Workforce and Infrastructure Equals Mission Success. And our success is truly made possible by our world-class workforce, which includes over 17,000 civil servants and over 35,000 contractors. This workforce is enabled by physical and core business infrastructure, laboratories, equipment, and facilities across NASA's locations that support our cutting-edge science, engineering, and operations. So this request provides $3.4 billion within the Safety, Security, and Mission Services account to fund agency-wide business capabilities, technical oversight, and infrastructure maintenance that are essential to enable NASA's ambitious portfolio of missions and help maintain U.S. leadership in space, aviation, science, and technology. It also provides $454 million within the Construction and Environmental Compliance and Restoration account to make sure the agency's infrastructure, laboratories, and critical facilities are safe, secure, environmentally sound, appropriately sized, efficiently operated, and mission ready. I'll move now to slide 10. In closing, before I get into the account details, this fiscal year 2024 budget request for $27.2 billion demonstrates the administration's strong support of NASA as we discover, explore, innovate, and advance for the benefit of all. The vertical blue box you see in the middle highlights the 24 budget request, as well as the out-year profile and how our budget is allocated down to the theme level. And we'll move on to the next slide, where we'll talk about the account level details. Actually, I think we can go to slide 12, where I'll start with deep space exploration systems. So the FY24 budget request for deep space exploration systems is $7.97 billion, which is a 6.7% increase over the FY 2023 appropriation. The request allows the agency to pursue the Artemis campaign and enable explorations of Mars and beyond. The Deep Space Exploration System account consists of 4 themes that I'll go into more detail in the pursuing slides. So move now to slide 13, where I'll talk about the request for Common Exploration Systems Development, which is $4.53 billion. NASA's CESD programs work together to build a space transportation system, which comprises the Space Launch System rocket, Orion Crew Vehicle, and Exploration Ground Systems, which we successfully tested last November with Artemis 1 test flight and safe recovery of Orion. The CESD request includes $2.51 billion for SLS to focus on successful completion of Artemis 2 and to make necessary preparations for Artemis 3 and 4, which includes the enhanced upper stage configuration and other upgrades. It includes $1.23 billion for Orion to finalize assembling and testing the Artemis 2 crew vehicle and to deliver the system to Exploration Ground Systems at the Kennedy Space Center. And it includes $794 million for Exploration Ground Systems to complete preparations for Artemis 2 and to develop the necessary ground systems, including the Mobile Launcher 2, required for assembly, test, and launch of the SLS Block 1B on Artemis 4. On slide 14, I'll talk about the request for the Artemis campaign development theme, which is $3.23 billion. And the overarching goal of ACD is to develop the systems that will be used to land humans on the moon, explore the work on the lunar surface, and prepare for Mars exploration. The ACD request includes $1.88 billion for human landing systems to develop and deploy multiple landing systems that will transport astronauts to the lunar surface. This includes funding and support of Artemis missions 2 through 5 to include completion of the SpaceX HLS demonstration mission and advancing the Sustainable Lunar Development Competition that includes Option B, SpaceX, and a forthcoming competitive selection for Appendix P. It includes $914 million for Gateway to continue development of the habitation and logistics outposts and the power and propulsion element. It includes $300 million for exploration, extravehicular activity, and human surface mobility, and funds the Lunar Terrain Vehicle, the surface pressurized rover, and XCVA surface suits that NASA will use to explore the surface of the moon. And it includes $60 million for advanced cislunar and surface capabilities, manage and integrate the systems that NASA will use throughout the Artemis campaign to access and explore the surface of the moon. Moving on to slide 15, the request for human exploration requirements and architecture is $49.1 million. HERA includes the Moon to Mars Architecture Development Office that supports mission manifest planning and overall architecture requirements and capability identification for Artemis missions and will inform future missions to Mars. The request for $49 million will support Moon and Mars architecture development, systems engineering, and integration efforts. Moving on now to slide 16. The request for Mars campaign development is $162 million. And the overarching goal of the new MCD theme is to work on long lead technology challenges that will need to be solved for future crewed missions to Mars. This theme encompasses one program, Exploration Capabilities, for which the request includes $132 million for developing key habitation systems, including life support systems and radiation protection, that enable the crews to live and work safely on the lunar surface. It includes $18 million for crew health and performance, including exercise equipment to maintain crew fitness on long missions, diagnostic sensors for remote medical care, and models to predict crew fatigue and risk from performing XCVAs. It includes $6 million for exploration capabilities core technology that will foster a sustainable presence on the Moon and Mars and enable a lasting presence utilizing reusable systems. And it includes $4 million to develop robotic precursors, including small robotic spacecraft and remote sensing instruments to search for lunar resources. Moving on to slide 17, we'll talk about our space operations account, for which the budget request is $4.53 billion. And this is a 6.7% increase over the FY 2023 appropriation. The space operations account is dedicated to sustained human presence in low Earth orbit, enabling future exploration and advanced operations in our solar system, and advancing scientific discoveries that benefit life on Earth. Moving on to slide 18. Within space operations, the request for the International Space Station is $1.3 billion. The ISS, now in its most productive decade of utilization, continues to advance research, provide commercial value, and foster global partnership. As a testbed for deep space exploration and microgravity research, the ISS is helping us learn how to keep astronauts healthy during long-duration space travel and demonstrate technologies for human and robotic exploration both in and beyond LEO to the Moon and Mars. This request provides ISS with $1.04 billion to provide continuous ISS operations, support extension through 2030, and enable a transition to commercial LEO destinations once available. And it includes $266 million for ISS research, including research and technology demonstrations for long-duration human deep space exploration, basic science, and earth science research in partnership with other NASA mission directorates. It also includes $20 million for the International Space Station National Laboratory to conduct R&D activities that foster commerce in space and benefit life on Earth, including cancer research as part of the President's Cancer Moonshot Initiative. Moving on now to slide 19. The request for space transportation is $1.96 billion. This request supports NASA's partnership with the U.S. commercial space industry to develop and operate safe, reliable, and affordable transportation to and from ISS and LEO. This request includes $1.86 billion for the crew and cargo program to provide for a regular cadence of crew rotations and cargo resupply missions to the ISS. This funding also includes $180 million for a competitive procurement with U.S. industry to develop a deorbit capability for ISS by the end of 2030, consistent with our international partner obligations. And it includes $101 million for the commercial crew program to certify and maintain technical insight into the vehicles that transport astronauts into space. Moving on now to slide 20. The request for space and flight support is $1.05 billion. SFS provides mission-critical space communications, launch and test services, and astronaut training to support its customer missions. This request includes $580 million for space communications and navigation to provide services for human exploration, science, and crew and cargo missions. It also includes $154 million for human research program to mitigate risks to astronaut health during long-duration missions. It includes $104 million for launch services to provide safe, reliable, and cost-effective launch vehicle acquisition for over NASA spacecraft missions. It includes $102 million for human spaceflight operations to support readiness and crew health for our human spaceflight missions, $59 million for communication services program to demonstrate commercial communication and data relay services, and it includes $49 million for rocket propulsion tests to support NASA's rocking test capability and commercial rocket testing requirements. Moving now on to slide 21. The request for commercial LEO development is $228 million. And this is a focused effort to ensure that there will always be a U.S. space station in LEO that meets NASA's enduring requirements even after the ISS is retired. With this request, NASA will support design maturation and testing of commercial LEO destinations with 4 U.S. space companies, and will enable private astronaut missions to the ISS and commercial and marketing activities on the ISS in order to mature other potential customers of our commercial LEO destinations. I'll turn now to slide 22, where I'll focus on the space technology request, which in FY 2024 is $1.39 billion, and that represents a 16% increase over the FY 23 appropriations. Turning now to slide 23. The request for space technology covers the entire technology readiness spectrum and includes $551 million for our technology demonstrations. and I'll just cherry pick a couple of the examples on this robust list. But under technology demonstrations, that includes supporting research into both nuclear thermal propulsion for $17.5 million, as well as nuclear electric propulsion, also for $17.5 million. And space nuclear propulsion will ensure faster transit times to deep space destinations, which will be critical for eventual human missions to Mars. The request includes $402 million for technology maturation to demonstrate several lunar surface innovation initiative technologies on the surface of the moon in partnership with CLIPS, such as the Polar Resources Ice Mining Experiment, or PRIME-1, which is the first in situ resource utilization demonstration on the moon to robotically sample and analyze for ice forms below the surface. This request also includes $138 million for early stage innovation and partnerships, which will include increasing space technology research grants to expand investments in graduate fellowships, early career faculty, and research institutions. And it includes $300 million for small business innovation research and small business technology transfer, and that will include awarding over 460 new awards, grants, and contracts to small businesses, and to improve our technology transfer access for minority-serving institutions and historically Black colleges and universities. I'll move now to slide 24, where I'll talk about the science account, for which the FY24 budget is $8.26 billion, and this represents a 6% increase over the FY 2023 appropriation. As noted earlier, science supports more than 100 space missions and focuses on 3 interdisciplinary objectives: discovering the secrets of the universe, searching for life in the solar system and beyond, and protecting and improving life on Earth and in space. Moving now to slide 25, I'll discuss the request for Earth science, which is $2.47 billion, and will enhance our understanding of the Earth system and our observations of climate change and its effects. This funding includes $292 million to support formulation of the Earth system observatory missions to enhance understanding of the Earth interconnected system and to observe the effects of climate change. It includes over $450 million in climate research-related projects to improve our ability to predict climate impacts, weather, and natural hazards. It also includes funding for the Earth Information Center. It includes $299 million to continue development of high-priority missions such as Landsat Next, CASE, Clario Pathfinder, and NISAR. I'll move now to slide 26, where I'll talk about the request for planetary science, which is $3.38 billion, and that request will explore the planetary bodies of our solar system. This funding includes $949.3 million for the Mars Sample Return mission to bring Mars samples collected by the Perseverance rover back to Earth. It includes $692.2 million for high-priority missions, including Europa Clipper, Viper, and Dragonfly. It includes over $250 million for the Planetary Defense Program to study near-Earth objects detection and mitigation, including $210 million for the NEO Surveyor mission. It includes $248 million for investments in a competitive discovery program, including a mission to Venus, Da Vinci, and Psyche, set for launch in October 2023, and supports several international collaborations with the European Space Agency and JAXA. Turning now to slide 27, the request for astrophysics is $1.56 billion to study the universe and search for Earth-like planets. This funding provides $349 million to operate the great observatories, including the James Webb Space Telescope, the Hubble Telescope, and the Chandra X-ray Observatory. It includes $407 million to develop the Nancy Grace Roman Space Telescope, which will better our understanding of dark energy, exoplanets, and infrared astrophysics for launch in 2027. It includes $259 million for the Competitive Explorer program and $39 million to complete the closeout of the SOFIA program, including dispositioning of assets and archiving science data. Moving now to slide 28, the request for heliophysics is $750.9 million, and the request will study the sun and its influence throughout the solar system. This funding includes $190.7 million to support a competitive Explorer program, including selected missions Muse and Helioswarm. It includes $139.8 million for the Interstellar Mapping and Acceleration Probe under the Solar Terrestrial Probes program. It includes $26.6 million in space weather investments to advance space weather science and applications, support interagency research efforts, and develop future space weather instruments such as Hermes. And it funds orbital debris and space situational awareness efforts to enable characterization of small debris and dust in space, protect space-based critical infrastructure and humans working in space. Moving on to slide 29, the request for biological and physical science is $96.5 million to better understand how biological and physical systems work by observing them in ways not possible on Earth. This funding includes $14 million for the commercially enabled Rapid Space Science Program, which will increase the pace of research and demand for R&D in low Earth orbit. It also includes $73 million for transformative research in 2 decadal focus areas, of which $35 million is for space biology, emphasizing thriving in deep space, and $38 million is for physical science, emphasizing quantum science. I'll turn now to slide 30, where we'll focus on the FY24 budget request for aeronautics, which is $995.8 million, and this represents a 6.5% increase over the FY23 appropriation. Moving now to slide 31, I'll delve into the details of the aeronautics budget. And with this request, NASA is leading the transformation of aviation in 4 key research areas: ultra-efficient transport, high-speed commercial flight, future airspace operations, and advanced air mobility. This funding includes $265 million for integrated aviation systems, including flight testing for the X-59 low-boom flight demonstrator, which will open the market to quiet supersonic flight over land. It concludes research from the X-57 Maxwell all-electric aircraft project that will support the development of manufacturing standards for electrified aircraft. And it continues work on 2 electrified powertrain flight demonstrators to reduce aircraft fuel burn and emissions, with first flights to occur in fiscal years 2025 and 2026. And it begins the initial design and build of the sustainable flight demonstrator, which will feature a truss-braced wing that will be more fuel efficient than current airliners. It includes $295 million for advanced air vehicles, including selecting high-rate composite aircraft manufacturing technologies that will enable high-rate production for large composite airframe structures and lead to a full-scale aircraft component demonstration in fiscal year 2026. It will award follow-on contracts to further advance new core engine technologies to reduce fuel burn for turbofan engines, with a demonstration plan for 2027. It includes $160 million for transformative aero concepts, including issuing new awards through the University Leadership Initiative, with emphasis likely on zero-emission aviation. It includes $159 million for aerospace operations and safety, including funding for NASA's Advanced Air Mobility mission, which aims to ensure U.S. leadership in an emerging aviation market. It funds publishing a concept of operations for advanced capabilities for emergency response operations with other federal, state, and local agencies to inform future NASA research to improve aerial response to wildland firefighting. And it includes $117 million for aerosciences evaluation and test capabilities, including continuing support for NASA's various mission testing needs for use of subsonic, transonic, supersonic, and hypersonic wind tunnels and propulsion test facilities at the Ames, Glenn, and Langley Research Centers. It includes developing testing methodologies to reduce flight certification time using the Langley National Transonic Facility. Moving now to slide 32, I'll cover the FY24 budget request for STEM engagement, which is $157.8 million. And this represents a 10% increase over the FY23 appropriation. Turning now to slide 33, with this request, the Office of STEM Engagement will invest in the Artemis generation of engineers, scientists, technologists, and explorers, and advance diversity, equity, inclusion, and accessibility priorities while doing so. This request includes $58 million for NASA space grants. That includes a funding augmentation to each eligible consortium. It includes $48.1 million for Minority University Research Education Program to implement multiple competitive award opportunities for minority-serving institutions, including leading the formation of an HBCU-focused element designed to address STEM research, faculty development, and student success. It includes $26 million for established program to stimulate competitive research to execute its multiple competitive awards portfolio in partnership with the National Science Foundation. And it includes $25.7 million for Next Gen STEM to focus on underserved and underrepresented student groups in NASA with using NASA mission content, including Artemis and the James Webb Space Telescope. Turning now to slide 34, the FY24 budget request for Safety, Security, Mission Services is $3.37 billion, which is a 7.7% increase over the FY23 appropriation. And this amount includes a 5.2% federal pay increase for our civil servant employees. The request also provides $453.7 million for construction and environmental compliance and restoration, which represents a 9.5% increase over the FY23 appropriation. Moving now to slide 35. The SSMS account supports NASA's foundational capabilities, including critical, physical, and business infrastructure and technical capabilities. The request for SSMS includes $910 million for NASA Center's Engineering, Safety, and Operations. It includes $802 million for mission enabling services that represent the agency's enterprise, business, and mission support capabilities. It includes $775 million for infrastructure and technical capabilities, $682 million for the Information Technology Program to modernize our IT capabilities and strengthen our cybersecurity posture, and $200 million for Agency Technical Authority. Moving now to slide 36. The Construction Environmental Compliance and Restoration Account funds capital repairs and improvements to NASA's infrastructure, as well as environmental compliance and restoration. This budget takes a risk-based approach to balance investments in maintenance, repair, and construction. And the CECR construction or repair activities are also managed and balanced against the SSMS maintenance activities to ensure mission readiness. The request for CECR includes $336 million to construct, repair, and revitalize institutional infrastructure across all centers, $78 million for NASA's environmental stewardship responsibilities, $29 million to support space operations mission work, including space communications and navigation, the ISS, and the Launch Services Program, and it includes $11 million to support exploration mission work, including SLS, Orion, and Exploration Ground Systems programs. Turning now to slide 37, the FY24 budget request includes $50.2 million for NASA's Office of the Inspector General, which represents a 5.5% increase over the enacted budget. And with this request, it will support OIG personnel, travel, IT training, and operational procurement. And with this request, the OIG also proposes a 2-year funding authority for the entire OIG appropriations to align with NASA's budget execution processes. Moving now to slide 38, the last slide of this presentation, and it's a favorite of mine. This slide displays NASA's mission planning manifest through fiscal year 2028 that is supported by this FY24 budget request. So with this budget, we fund 148 NASA missions that will enter operations. And if you look at the timeline at the bottom by fiscal year, you'll see also that there are some mission stacks that are outlined in yellow, and those represent those missions that are in support of Moon to Mars. As I noted previously, this includes missions from multiple mission directorates and involves both robotic and human missions. And at the top of the annual mission stacks, you'll see outlined in light blue, those are those Earth science, green aviation, and planetary defense missions that support protecting our planet. So one reason I love this graphic is it highlights the tremendous amount of activity as well across the breadth of NASA missions. And let me not forget those in the middle that are not highlighted or surrounded by a line that represent equally important missions that will be operated across NASA. So let me walk through some highlights from each of those fiscal years. So in FY 2023, we've already completed 7 of the missions shown here. And in addition, we have ahead of us this year the ramp-up of Moon to Mars activity that will continue with a series of commercial missions delivering science payloads to the lunar surface as a service, as well as multiple technology demonstration missions. We'll see the crew test of the Boeing Starliner, the first flight of a new cargo capability to the ISS with the CRS Space Dream Chaser. We also see testing of the new X-plane from our Aeronautics Research Mission Directorate, the X-59 low-boom flight demonstrator, and initial flight testing. We will launch 4 Earth science missions, including TEMPO, to measure the pollutants we breathe in North America, and TROPICS, a constellation of small sats to measure storm intensity. In FY 2024, we will pave the way for the return to the surface of the moon with the uncrewed demonstration of the human landing system, as well as more robotic landers and delivery of the Viper rover to the lunar South Pole. We'll launch Psyche, a mission to a unique metal asteroid between Mars and Jupiter. And we'll also continue landing technology demonstrations aboard commercial lunar payloads, including Cadre, a set of shoebox-sized rovers that will work together without human interaction to explore and map the subsurface of the moon using ground-penetrating radar. FY24 will also see the launch of PACE, our plankton aerosol cloud ocean ecosystem, that will improve our understanding of how the ocean and atmosphere exchange carbon dioxide. There will also be a steady cadence of commercial service missions to support the ongoing operations and research of the ISS, and several exciting science missions that will strengthen our ability to monitor the Earth's changing climate. In FY 2025, we will send humans into orbit around the moon with the Artemis II launch, and we will be sending another explorer to the outer solar system with the Europa Clipper mission. Several new missions to study the sun and solar wind, as well as other exciting science missions. NISAR, our collaboration with the Indian Space Agency to improve management of natural resources and hazards, is planned to launch in October 2024. And the ISS supports missions that will continue, and aeronautics will demonstrate an electrified powertrain that will enable aircraft propelled by megawatt-class power systems. By fiscal year 2026, we will see the return of humans to the lunar surface with the Artemis III mission, the initial elements of the Gateway in lunar orbit, and additional robotic payloads delivered to the lunar surface. We will continue ISS support, build up the capabilities of Gateway, and continue lunar technology demonstrations supported by commercial robotic landers. In fiscal year FY 2027, we will see exciting science missions including the Roman Space Telescope and Dragonfly, a robotic rotorcraft that will explore the surface of Titan, the largest moon of Saturn. And finally, in FY 2028, we'll see the introduction of the powerful SLS Block 1B with the Artemis IV mission, a lunar terrain vehicle, and demonstrations of technologies needed to extract resources from the moon. And the NEO Surveyor Planetary Defense mission will also launch that year. In closing, the President's budget for NASA is an investment in our nation's future. It is an investment in U.S. innovation and competitiveness, and it is an investment in our next generation of workers. That concludes my overview of NASA's FY 2024 request. I'll hand it now back to Catherine. Thank you.
Thank you very much. We'll now take questions from reporters on the line. Those on the phone can press *1 to be entered into the queue at any time, and press *2 if you'd like to be removed from the queue. Your lines are on mute now, and the operator will open and close your mic when we come to your question. We ask that you please keep it to one question so we can get to as many of your fellow reporters on the line as possible. Our first question is from Jeff Schaus of Space News.
Good afternoon. I want to ask about the ISS deorbit tug that's included in the budget request. What does that $180 million get you in terms of development of the tug? And how much does NASA anticipate spending on the development of the tug until it's ready for flight late this decade? Thanks.
Bob, would you like me to take that?
Yeah, go ahead, Kathy. I'll chime in if I need to.
Okay, so Jeff, when we were working our estimates, and obviously, we worked through the process, and this is all predicated on us getting final proposals, but the cost estimate we had was a little bit short of about $1 billion, and the budget is $180 million for our fiscal year 24 portion of that. Our goal is to go out with a RFP, and obviously when we get the proposals in, we're hoping to get a better price than that, but this gives us a healthy start in 24 for us to get that critical capability on board.
Thank you. Our next question is from Marcia Smith of Space Policy Online.
Thanks so much for taking my question, and mine has to do with Mars. I was wondering if you could provide some specifics on how much NASA plans to invest in the ExoMars program. I know the request says you're still talking with ESA about exactly how you're going to split that up, but what have you got for this year and in the out years for ExoMars? And related to that, what is the plan to revitalize the orbital communications infrastructure for Mars missions like ExoMars?
All right, so this is Nikki Fox. I'll take the ExoMars. So we're still determining the exact amount of the contribution, but the current budget request does include $30 million in 24.
And Marcia, will you repeat the second part of your question about the communications infrastructure?
Right. So the orbital assets around Mars that provide the communications between landers and rovers like ExoMars are getting old, and I haven't seen anything in the budget planning as to how you're going to revitalize that, launch some new orbiter that can provide that communications relay. Is there anything in the budget? And Nikki gave the $39 million for ExoMars in 24, but is there anything for the out years?
Yes, so for the out years are not determined yet. That's part of the future Mars strategy that we're working on.
And the orbital communications?
Yeah, and currently right now there's not anything currently in the budget for those, but that doesn't mean that as Nikki matures her strategy, we wouldn't be looking at complementary capabilities that would support that. But currently there's not anything earmarked for that specifically.
Thank you. Our next question is from Richard Trubeau of Orlando Sentinel.
Hi, thanks for taking my question. Going through the budget, there was a line saying the Mars sample return costs may increase beyond the out-year profile, and it might require either reduced funding for other science activities or descoping of the mission. What are your, I guess, what's the projected total cost at this point? And it seems kind of ominous. I was wondering if you would speak to that topic. Thanks.
Yeah, sure. We are working through all of the preliminary design reviews for all of the major subsystems right now, getting ready to do a culmination for the mission PDR later this year, and then moving on to confirmation. So we'll have a budget at that point. Right now, we have not made it. There's no agency baseline.
Thank you. Our next question is from Jim Siegel of NASATech.net.
Hi, everybody, and thanks for taking my call. I'm interested in what upcoming initiatives for the ISS are on the horizon. I'd like to write a lot for my readers of initiatives that will benefit those of us back here on Earth. And I wondered if you could list a few of those that are coming up that would fall into that topic. Thank you.
So let me jump in a little bit, and thank you for your interest. I think we are learning how to use the ISS more and more as a platform, which I think is so exciting because we talk about this decade of results. And so what's been happening is we've been really working with folks that have been able to do their science in a more compact and in a way that enables to do the science. So we talk a lot about the tissue chip capabilities. We talk a lot about protein crystal growth. Those are all science capabilities that where the providers have more and more been able to refine their science in a way that it either can fly up in a smarter packaging, or also helps us be able to get results on orbit. And so I think as you're going and you're looking at things in the future, really what's going to be happening is not only the kind of science is going to be expanding, but us being able to get results and be able to assess on orbit, so we're not having to wait until we bring samples back and understand them. We can actually start getting and collecting data on orbit. That's, I think, going to be the really amazing innovation over the next, 6-7 years as we're fleshing out, the use of the ISS. Let me just give you a couple of statistics. We just extended we have over 2,500 peer-reviewed publications with over 5 100 of those being in top journals. And if you would have looked at this over a year and a half ago, it would have been a little bit over 1,000. So you can start seeing this trajectory of us getting science published out there in these top journals and really being able to take advantage of it. The other thing that I love is that in 2023, we're projected to touch over 3 million students here on the earth. And if you would have looked at this in 2020, it would have been 1.5 million. So I'm just going to tell you my goal is next year that would be 4.5 million. And I know Mike Kincaid, our head of, my fellow AA is rooting for us to continue to do that. So that's just a few statistics for you.
Thank you. Our next question is from Micah Maidenberg of the Wall Street Journal.
Hi there. Good afternoon. Just given the budget, the increases in the budget request relative to the last fiscal year, or the current fiscal year, I guess I should say, for various elements of Artemis, is the agency still sort of on track to lower kind of per flight Artemis costs or per mission cost as leadership has discussed in the past? Thanks.
Yeah, Micah, this is Jim Free. Thank you for the question. Absolutely, that's our goal as we look to implement the current contracts we have to do that with our Orion production and operations contract that we have with Lockheed. As we look at the out year Orion missions and putting those on contract and driving those costs down. For SLS, the current SLS program under John Honeycutt has a series of affordability initiatives that they continue to put in place. And as we look at bringing on our exploration, production, and operations contract, which is intended to consolidate some of the SLS contracts we have today and bring those down, our exploration ground systems program at Kennedy under Sean Quinn and then the Center Director there, Janet Petro, continuing to look at ways to do the processing of the vehicles more efficiently, especially after what we learned on Artemis 1. So across the board, just on our crew transportation systems, we're looking at those ways to bring our overall Artemis cost down.
Thank you. Our next question is from Passant Ravi of Gizmodo.
Hi. I had a question about the ISS deorbit as well. So is it now NASA won't consider using the Russian cargo spacecraft for deorbit of the ISS anymore? And is there a reason behind this new direction to rely on commercial partners instead?
I'd say we're always looking for redundancy, and so obviously our current model is still to use, and we're continuing to work with our Russian counterparts on how to deorbit safely with their Progress vehicles, which has been in the plan. But we are also developing this U.S. capability as a way to have redundancy and be able to better aid the targeting of the vehicle and the safe return of the vehicle, especially as we're adding more modules. And so, as you've seen in the past and over this last year, us having these redundancies has been very, very important for both ourselves and our partners. And so having the U.S. deorbit vehicles is another key linchpin in our safe operations and deorbit strategy of the ISS. Thank you.
Thank you. Our next question is from David Curley of the Discovery Channel.
Thank you very much, Catherine. Bob Cabana, the budgets are statements of priorities. I think I can see what you're doing here, but in your words, can you describe what the priorities of this 2024 budget is? And one other question is about human landing systems. You show, going through Artemis 4 and then TBD. What are you thinking, Starship versus a smaller human landing system? All the graphics seem to show us smaller vehicles. Thank you.
Thank you. I think Margaret laid out our priorities pretty well. We want to continue to establish our exploration program to learn on the moon as we progress on towards Mars. We want to continue to learn about our planet and the Earth observation system. And we're going to continue our leadership in aeronautics and invest in new technologies. From an Artemis 4 point of view, we're doing our very best to keep it on schedule. Yes, it slipped a little bit, but we are going to work. There's a lot that has to come together for Artemis 4 between the enhanced upper stage, the gateway logistics, the second mobile launcher, and all of that has to work. The other point I would add is that, yes, we do want to get to a yearly cadence on Artemis. And as far as the human landers go, that's critical to have that human landing system so that we can get on our yearly cadence. We're still pressing to make Artemis 3 in 2025 and proceed on from there. It would be really beneficial, as Kathy mentioned, about the need for redundant systems, for that dissimilar redundancy, to have a second landing system through Appendix P. And we're going to press forward with that. I'm looking forward to seeing what we get back on our proposals. And I know Jim and his team are working really hard to ensure that we have both the SpaceX and other landers. Competition is good, and dissimilar redundancy is excellent.
Thank you. Our next question is from Teresa Foley of Aerospace America.
Hi, everybody. I'm hoping that you can add a bit more detail to the Psyche budget and mission description. Specifically, cost, has it gone over any more? The schedule, I think you did mention, and just in general, is this budget that is being released today, does it reflect some competition perhaps between the Artemis-connected missions and some of the robotic spacecraft when you're trying to figure out how to cut up the pie? Seems like Artemis may be taking more priority. If you could comment on that.
Sure. So the numbers that you see for Psyche will get us very comfortably to launch, which is on schedule for later this year. There are some additions to Phase E, just because of the later launch and a change in the mission ops. But actually, it's not a huge increase, so we're very happy about that. And no, we're not seeing Artemis taking away from any of our science missions.
Yeah, Nikki, and if I could add to that, when you look at the budget for SMD compared to explorations, SMD actually has a larger budget and an increase from last year. So I think the science mission budget is very well funded, and it's a priority for us.
Yep.
I also want to add to that our human exploration, our robotic exploration are absolutely complementary. We need our robotic exploration missions in some time to help pave the way for getting our humans back to, whether it's a sustainable lunar presence or back to Mars. And then to your question about further details, there is much more detail in our congressional budget justification chapters that are also available online. I hope you enjoy. I think it might be nearly 1,000 pages of detail on the NASA budget request.
And you can find that at nasa.gov/budget. Thank you. And our next question is from Lenka White of Sputnik.
Thank you very much for this briefing. It was very useful. Quick overarching question, please. NASA's budget is much higher than of its competitors like Russia and China. How crucial is this to have this bigger funding for Mars and Moon exploration? And secondly, sorry if I missed that, is there anything allocated for your cooperation with Roscosmos? Thank you.
So there's a small amount that we support Roscosmos with our International Space Station on-orbit services and the FGB, but it's to continue to support what we've been and what's been approved congressionally for us to support capabilities on orbit the ISS.
Yeah, could we repeat the question? I didn't.
And the first question was, how crucial is this funding for the Moon and Mars?
So the funding is absolutely crucial for us to continue on our Moon to Mars effort. If we are going to continue to meet the deadlines and the goals that we've set for ourselves, it's very important that we have it funded.
Thank you.
Those are all the questions that I'm showing in the queue for today's call. So we will conclude today's call. If you have additional questions, please reach out via email after the call. And thank you, Margaret and Bob and all the members of NASA's leadership team who joined us here today. A replay of this call is available on the NASA Video YouTube channel, and all of our budget documents are available online at nasa.gov/budget. So with that, this concludes our teleconference, and thank you for joining us.